Okay, good evening. I said I was going to record in the morning and then didn't because I slept in and then I did a bunch of housework and then went shopping and then worked on installing a backup and front-facing camera and just did a bunch of stuff and then chilled, whatnot. And now I have the oven warming up to make dinner. So it's gonna be another shit video. So I'm gonna intro right now, and then I'm gonna eat and chill, and then I'll probably be back later to um to just do a leak code and then get off here. So um like I said, I don't really have that high of expectations for these videos. I'm kind of just working on applying to internships right now, and getting ready for school, I guess. Not really. I have nothing to get ready for. I'm just saying like these videos will be a lot better because I'm just going to end up recording my schoolwork, and so that'll be a few hours every day. Um, so yeah, for now, one leak code a day, um, maybe two if I do it earlier, and if I really have nothing to do for the day and I wake up early, then also working on a project. So, um, but yeah, nothing has really happened that would be of interest to talk about between last video and now. Really nothing at all. So might just pause it here and then we'll be back with the leak code. Um, I think there's anything I wanted to talk about. Uh, uh, um, Pretty much at 200 applications. Still nothing for an interview. So just gotta keep on applying. Um, yeah, I've heard a lot of companies like February uh is when they like send out stuff like so. Just gotta apply as much as I can this month, and hopefully I get some responses in the next few weeks. But yeah, I also haven't read the book that I wanted to do reviews on just because I mean my schedule has been quite shit these last few days since the career fair. Um so yeah, gotta fix that up. But anyways, so I'm just going to pause here. Maybe I'll have something to talk about when I get back. If not, we'll just do the leak code and call it a day. So yeah, I'll be right back for the leak code. I am back. I think I'm gonna do a leak code actually because I will look at the leak code, but um also, you know, so I don't actually have a. I always hated using a Keurig because I just like the default pod flavors are always just like eh, and they never taste like a nice fresh brew of some like grounds. And I didn't know that Keurig has like you can pop out like the thing in the Keurig that like sits the pod, and they have a reusable pod that you can fill with like grounds, and it'll just pump hot water through those grounds. So pretty sick. And I got the only thing is I do like whole milk in my coffee, and I ran out of whole milk unfortunately. Oh, I have a fucking spill. I ran out of whole milk, so black coffee for now, I guess. Um, um, but yeah. Anyways, we're just gonna do one quick leak code and then call it a night, call it a day. And then I'll make the what false promise of getting on early tomorrow. Yay! Okay. Anyways, um, so I want to see what LeetCode has because we finished. I'm pretty sure we finished. Oh, cool. So this is the entire. That's not what LeetCode 150. If I go to roadmap, no. If I go, anyways, so we finished backtracking intervals. We have one. We could do. No, I said this one was. Let's look at LeetCode. See if there's anything that catches the eye here. I can go back to actually on here it might be still dark mode. Maybe. Okay, nice. LeetCode 75. 2-pointer sliding window, prefix stack. Asteroid collision. But I can just like select like a random. Let's do random number between 1 and 75 and then count to whatever that is. 37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Lowest common ancestor of a binary tree. Oh, this doesn't look fun. Give it a binary tree. Find the lowest common. Right here, let me. All right, given. Oh, I also wanted to full screen this. Binary, find the lowest common ancestor of two given nodes in the tree. According to the lowest common ancestor in a tree is two nodes P and Q. As the lowest node in T that has both P and Q. Wait. The definition of the least common ancestor within a binary tree. The lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q below it. Okay. So given this tree, P is 5 and Q is 1. The least common ancestor. I'm so confused. Let's look at this one. P is 5 and Q is 4. I'm sorry, I don't get this like at all. Oh. You're given P and Q and the tree. So you're given this tree with 5 and 1. And so you need to find the lowest common ancestor of the two given nodes. The lowest common ancestor is defined between two nodes. So here you're given 5 and 1. The least common ancestor of nodes is 3. Okay, but I still don't get it. Here you're given 5 and 4. Oh, it could be itself. Okay, so if we were given like 6 and 4, it'd still be 5. Because we're trying to find the earliest, like, I guess, parent or just okay. I think I understand it now. So given two nodes. So if we're given 5 and 1, right? Find the lowest common ancestor. So the lowest common ancestor is 3 because these are how this is how they're related. Is by 3 and nothing else. In this scenario, when we have 5 and 4, technically they're both related by 3, but you can include itself. But if you had 6 and 4, I'm pretty sure it's still 5 because that's the least common ancestor, right? And if you had a tree that was 1, 2, and P and Q, then okay, yeah, then it'd be 1. Okay. Okay, so how would we solve this? Make. Oh my god. Can I not? Hello, thank you. I still want to like. Is there settings? How do I make a code editor? Yeah, 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 yeah. Give me like 18. Yeah, nice, nice, nice. And actually, I can then low key scroll out one. Okay. Also, I hate line wrap. I am not a fan of line wrap. Okay, so given the number of P and Q, we need to traverse this tree and we have to find P and Q, but given a path, right? So if we looked and we started at like 3 and then we go to 5, so we know that 5 is connected to 3, right? And then we go down to 6. Sure. Then we go down to like 2 and then we find 4. And how would you do this? Hmm. Because like if at any point you have if one of the numbers was ever 0, 1, or 8, and then the other number was anything over here, it would be 3, if I understand it correctly. So we just have to find the latest node it could be that connects these two. Oh my god. If I'm thinking of a brute force way here, right? If I took a path until I hit a number, right? So let's say it's 5 and 4. And so I hit 3, and these are all distinct numbers or no? Let me What are these cases? Null, null, 7. Oh wow, it actually just gives me a representation of the tree. Okay, if we're assuming that it's unique numbers, right? If we did a path, right? And so give them 5 and 3. We go from 3, we do a DFS, and we find 3, 5, right? If it equals the node, then take whatever the current path is and append it, you know, to just to an array, right? And then we keep going and we find the path to 4, which is 3, 5, 2, 4, right? And so we look at this path and we take the last element that is similar in both. So even if it was 8, right? Say we had 3, 1, 8, and then we had 3, 4, 2, 4. Well, the only thing that's common here is 3. So we just take 3, right? If we had 3, 5, 6, right? And then 3, 5, 2, 4. Again, you just take 3 and you take 5. So I think that is going to be what we want to do. So we want to do a depth first search. Um, for now, I will just have something called res, and we'll do a depth first search. Now, the depth first search is going to have the current node And the current node, I don't like that has a, oh no, it's just because it's an argument. Okay. So we have the current node that we're passing through. I also want the path. Okay. And now do I need anything else? I don't think so. So what is our base case? Our base case is if the node dot value is equal to P, or the node dot value is equal to Q, right? Oh, these are tree nodes. So would it be Q dot val and P dot val? Right. If either of these hit, then we want to do a res dot append the current path. We just want to append the path. Probably a path dot copy, right? And then we want to just return, I think. Okay. So if we find either of these, we want to append its path to res. No matter, and so if that doesn't hit, then what we want to do is we just want to say the path dot append node dot val, right? And then just call DFS on both node dot right or node dot left and DFS on node dot right. If none, and then path is just going to be whatever path is after we append this. I think. I'm forgetting something here though. It just slipped my mind. Well, obviously we're going to want to call DFS with root and this, and then return. Well, and then we want to do, well, before we return, I'll say return res, but I want to, here we can literally say res at 0 at 0. It's not the answer, but I'm just saying. I want to print res just so we can see this for right now. So what's gonna happen? We're gonna go through with just the here, and we're gonna look. Oh, that's what I wanted. I want to say if node dot left just if node dot left. Is that valid? I don't know if that's valid. Let's just run it. I think we're getting a syntax error on that. Um. An object has nothing. Node dot val. For what? Anyways, it ran through, but it's something on this. I think I have to pop. So if I go through, right, and we look at 3 first, and we append this to path, so we do, so path now has 3, and we say DFS node dot left, which would be 5, right, and our path is 3. Okay, it equals this, and then we do res dot append copy, and we do that. So it's going to return with just 3. Why do I always mess this up? Um, because what's happening is because we got 3, 3, right? What was my int object has no attribute val. What would node dot so a p and q? I don't think it would ever be that is wrong. I don't get what it's so mad about. But like where? Out equals string ret dot val. All of these are tree nodes. I'm passing through this. I'm accessing P and Q as a dot val. There should be no reason why this is being passed through as just the node. So doing a node dot val is also valid. Let me log in. If node.pal, fuck you. I said don't. Oh my god. I hate. Oh my god, I'm so mad. Okay. Just append the node, it's saying. Path.append the node. And then to backtrack, I need to do a path.pop. Oh, and then I can do, I'm pretty sure it was saying I can do, actually, what was it saying I could do? Node.val equals p.val or node.val res. dot copy path return. Oh, if node equals p. If node equals p. Oh, because I guess it is not a. That really fix it? Nothing there. Why would there be nothing there? Will this give me the 3-3? Nope. Node.left DFS node.left. I mean, okay, that's giving me the whole solution. I don't want that. Okay, so what's happening right now? We're passing through root with an empty array. And then we go through, and I don't care about the if node is none. We're looking at this test case. If node is equal to p. So if our current node is equal to this, if this tree node is equal to this tree node, if this node is equal to this, or this node is equal to this, res.append path.copy. Now, I won't lie, I still want this to be the node.value. Let's look at this. Okay, at least it's appending this now. But here's the thing, I'm never using a .val on. I'm using a .val on this node. Okay, current value equals node.val. Doubt this changes anything, but I'll just try it. Int object has no attribute val. Oh my god, why, bro? Let me .val. Just .val everything. I'm doing one .val. That's it. So right here, it just doesn't like this. Int object has no attribute value. Node is being passed through as root, which is this. Does it need to be a self.root? I doubt it. Oh wow, look at that. It's just root. It's just root. I pass through the root. I just don't get it. If I do this, right? I got that, sure, but it doesn't append anything. Let's just return 1. Do I get any errors if I do this? Okay. Okay, no. It literally is just acting up. I hate LeetCode. Anyways. What is that? Jeez. Okay, okay. Also, there's a problem of we are appending this, but we're never actually, we're saying if this, then what I want to do is I want to do a node, I want to do a path dot append node dot val. Wait. If I'm going through the first time, right, and we're saying the current value is equal to 3, right, and then we append it and we go through. Yeah, I'm never checking this again. So actually it should be this actually just goes first. So if node, or just if not node, what? Just return. Um, Otherwise, what I want to do is this first, actually. Let's run this. 35351 because it went 35351. How would that be 351? I want it to go 3 and then it goes 5 and then it goes 1, but it should never be a, oh, you know what? If we do 3 and we do a call on it, like in this scenario, when we do a node.write, this should never ever give us ever a base case response, right? But when we do node.left, we should have 3, 5, and then when it goes right and left, it should be adding this, and then if it goes to 7, right? If it goes to 7, that's when we want to be popping, right? It's like if we go down like a bad path, we want to pop until we find the good path. So let's just look. We go, I can't believe how is this ever giving a 1? It has to be that it's like somehow going back to like the root and calling, I don't even know. So if not node, return the current value. So we're at 3. We append this and we check if this is equal to either of the values, 5 or 1. It's not. Oh, this one actually is. Actually, 3, 1 is what we want here. Sorry. But why is there a 5 there? It's because it didn't pop. So technically on this dot, both of these should go down 5 and 1. It's that value was never popped. Maybe it should be.
I'm dying in some crazy ways. The first players that we've
Sorry about all that. Press the wrong button. But it should be. There we go. Because this still may not be right, but if there's nothing, if there is something here, right, on from this node on the left, right, run DFS, it does this. If we have a return on that, right, and we come back, we want to pop off. I mean, we kind of just want to pop it off whenever we're going to here. So, anyways, but what we want to do is we want to find the overlap. So we want to look. The most brute force way I can think of doing this is just doing. like a for each in res at 0 if res at 1 at, and then this is going to be index enumerate if res at 1 at index does not equal well, actually what I can do is if res at 1 at index is not equal to each, right, then I just want to take res at 0 res at 0 at index -1 and just return that, right? Oh my God. Okay, I can't do this. Oh my God. I can just say return. Um, but it still doesn't like this int object has no attribute val. I know it's embedded, but why not? Okay. Jesus, bro. I see it closes. Oh my God. What time is it? 10:08. Uh-oh. Okay. Does it really want a tree node? There's no way it wants a tree node returned. I'm gonna be so pissed if this actually works. Pop from empty list. Cheers. List index out of range. Okay. Let's print off results. It's all tree node shit. I love it so much. So fucking much. For each in res at 0, print each. Can I not just do this and then right here just say result equals this, and then afterwards just say result, or no. Result equals a tree node of this. Now I have no return value. So all I got was 3.5 because we're not popping here. Oh my God. If path, pop. If path. Sorry, if the length of path is greater than 0. Oh my God. Wait, what? Oh, I did. Still 3.5. Was it not like working earlier? And what changed here? Not a thing. Okay. Let's copy this. And that says, okay, sick. Okay. So for each in res at 0 and index enumerate if if res at 1 at index is not equal to its adjacent res, or just each, then we can return res at 1, or sorry, a tree node of res at 1 at index -1. Isn't it just weird though that like before, I don't know. Okay, whatever. I admit defeat. I don't understand. Okay, let's just go through this logic one more time. We start with 3. The node 3 gets passed through. Is it P or Q? No. So we go and we see if node dot left. Well, there is a node dot left, so we're going to call DFS on node dot left. Okay, in the current path, which is 3. We then go through and we append 5. 5 is appended, and we say, okay, is the current node equal to either P or Q? It is. So we res dot append a copy of the path. So 3, 5. And then we return to the previous call. So we return here and then we pop. So we pop the 5 off, right? And we're at node 3. Or no. Wait. What node are we at now? Are we at 5 or are we at 3? We should be at 3. And we say, okay, if node dot right, there's a node dot right. Depth first search, node dot right with path. So we find that node dot right with the path. We add that, bam, it should be both and it should be appended. I give up. If I take off the pop, if this works, I'm gonna be so sad. Because this is literally my fucking code almost bar for bar. I mean, what's changing here? This is the same, this is the same, this is the same. This is what we did earlier. Except we just did it outside. Do I need it to be in here? Doubt it. If the length of the result is less than 2, we return none. If one path is a subset of the other, I don't see what this would be needed for. Okay, this case worked. This case didn't. Output null. Wait, What? 3, 4, 5, 1. If one path is a subset of the other, why would I ever need this? Also, I feel more so like if it's less than here, then just fuck it. Return res at 0 at -1. Bam. Sorry. A tree node of that. Oh my god. Oh my god. If this goes through, I'm going to lose my mind. In what world is ever returning the last fucking... This can't be real. What happens if I remove this stupid ass return statement? Okay, so prove that. Okay, nothing changed from my original approach other than nesting the if statement. Because I did if path pop. We did that. Does this really mess it up? Okay, it does, which I get makes sense. Okay, it's saying like it's just as long as there is a right, then come back, and if there's a path, pop. Sure. But in what world? In what world are we saying, oh, I couldn't find... So is this the scenario in which okay, when I run this, right? And we go and we look at, because it was solving this one, right? Into where res is only one thing that's popping out. This is also only one thing's popping out. So on here, 1, 2. I'm guessing what's happening is we're going through one and we're like, yeah, this is correct. And then we go back. So what's happening is we're saying we pass through node, we append it to our array, and then we say, okay, is this node? Yeah, it is. So we append this and we return. We just return because we never even got to this. We never even got to a recursive loop down here. And so in this scenario, right, in which I'm only getting 3, 5, we go through on 3, and so then it should check both sides, which is a 1 and a 5, and it appends the 5, backtracks, and then never appends the 3, 1. Wait, whoa. This is going to be 3, 5. 3, 5, 2, 4 would be the two things appended here. It only appends the 3, 5. Why? I don't fucking know. Uh, we're going through. Bro, and even this is the craziest shit as well. ChatGPT said to return none, right? I changed this to returning the last element in the first array within the array and removed whatever it was doing here. I mean, this is doing if the first array at the minimum value of the like what is this saying? The minimum value between the length of the first one and the length of the second array minus one, return that. Like, I don't even know what. Okay, a tree node of the first array, okay, at the minimum of between the length of that first array and the length of the second array minus one. Cheers. So just remove that. I, I don't know. I don't get how this worked. I mean, okay, I understand like in that regard that it's like technically, right? If it's not on the right side and it's on the left side, whatever the last element of the path to whatever we find first, but not even because when we go to 3, 5, 6, right? If 6 was the one, right, then 5 would be the element we want. So that wouldn't be the last. Oh my God. This is crazy. That actually work. Oh my God, it worked. I don't get how that's returning null though. Outpulls none. A tree node at index minus one. For index and range. So that this goes for the smallest one, right? Okay, so this would just be else return a tree node of res at 0 at index. Why would this ever output 3? This isn't gonna hit. Okay, first off, remove this. I don't want this anymore. The minimum range would be 1 and 2. So we have 0. Let's just print off that index real quick. If res at 0 is not equal to res at 1 at index. So these are equal. Oh. Sorry, this should be after everything's done. So technically, wait, what would this be? Just its last element, right? Oh, well, it would have to be the shortest one. Sorry. Um 'Okay, this is really stupid, but if I set a variable of index and then I simply say index less equals 1, and then right here I just return that at the index. Two. Ah, beautiful. Yeah. Okay, I mean it makes sense. It looks a little weird, but it does make sense because it's like on this first iteration, we're going to be looking at index 0, but we're setting the index to 1 here, right? So technically we want it to start at -1. So when we do this first loop, it'll set it to 0 when it's checking 0, and then set it to 1 when it's checking 1. So it makes sense. It's just funny. Um, so this version makes a lot more sense to me. So removing the return here makes it so that when we return back to, so if we were to go um sorry, if we were to go 3, 5, right, 6, I'm assuming it's gonna be no. What happens if I remove this though? Yeah, I'm assuming it breaks, but I don't get why. The only thing I want is popping. So we start at root, explore the left, append 5, path is copied, and then we see 6, append 6, no match, PQ. So then we backtrack. So that's what I assumed, but how is this working in the code is my question. So it's like, okay, if node dot left. Oh, that's what's happening. Is it saying, um, so do I need to, the only thing that's interesting about this is it's an if node dot left, and then it's calling this on node dot left. And I'm assuming what's happening is it's coming through as, like, if I print off node dot val, let me run this, and we look at all the values that come through, right? We have 3, 5, 6, right? And then we backtrack and we pop here, and then I also want it to print off path. 3 with nothing, 5 with 3, 6 with 3, 5. Then we pop 6 off and we go 2 with 3, 5. Add the 2, 7, nothing with 7, so we pop the 7 off. And then 4 with 3, 5. Append it. And then what? Just a bunch of returns all the way back until we get 3 and then 3, 1. So then the overlap is just 3 and we return 3. Okay. So we call 2, sorry, we're at node 5. So we say if node dot left, which there is a node dot left, right? DFS call with 5 and the current path, which is 3. Okay. We go through and we say current value equals node dot val, append that. So now we have 5, 3. Is 5 equal to P or Q? It is, so append it. So append 3, 5. And then we go through again and we say if node dot left, which there is a left node. So we call it with this. So we do C and we append it 3, 5, whatever. We go through and it says if node dot left. Now I'd assume it now would skip over this and we wouldn't pop. Okay, so okay, wait. So does this just mean that it's if node dot left, if node dot right? So both of these don't hit at 6, right? It doesn't have a left or right. So does it just return to the previous call, and then it says, okay, if there's a path, then pop it, and we just pop it? That's all that's happening? So we call it with 6, node equals 6, we append it. Since node.left and node.right are run, the recursive calls for this and this do not execute because these fail. After skipping the recursive, the function returns to the previous call, which calls pop. I see. Okay. Yeah, yeah, yeah. That makes a lot more. I didn't actually know it defaulted. I mean, it makes sense. I didn't know it defaulted to going back to the last call if you have no statement of return. I assumed it needed a like it would error if there wasn't a statement of return for it to go back to. So that's nice to know. Anyways, I need to end this video because I still need time to upload this before midnight. So it's, day 56 that's uploaded. Um, pretty good problem, honestly. Our solution was pretty much solid. The only thing was uh, 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 embedding the pop inside of the call, which makes sense, right? Because now we know that it can return back to its previous call stack without a return. So what was happening is it was hitting both. There was no node left or node right. Or no. It was popping no matter what. So it was hitting a pop and then hitting a pop, right? Um, but we need both pops for afterwards. So a way to not hit both pops when it doesn't hit both conditions is embedding those pops. So it makes sense. Yeah, that actually taught me even more about uh like a binary tree because like I said, I didn't know that it would return to the previous call without just like saying return. Um, so that's nice. Um, uh-oh. But but yeah. So plan is I'm probably gonna read some of my operating system book tonight. If anything interesting comes up in it, I'll talk about it tomorrow. I'll try to. There's some nice football games on tomorrow, so I probably actually have some the best football games all season tomorrow. So I definitely need to get up before the first one starts to record because I probably just won't be available the whole day because I'll be watching that. So my roommates are probably going to be showing up within the next couple of days, so I don't know what these videos are going to look like. I don't know if I can talk at this volume because these walls are quite thin. So hopefully I can, I'm not whispering into the mic from now on for these videos, but we'll see. So so yeah, so I will end it here and see you tomorrow. That oh, one thing quickly I wanted to look at was just other solutions here. Mm-mm-mm. Wow, what the fuck? If not root, or if root equals p or root equals q, return root. Oh, it's just using it itself and saying and just passing through p and q all the time, and then it's just saying root dot left, root dot right. If L and R return the root. Interesting. That's pretty cool. Using a stack. Huh. All right, cool. Anyways, yeah, ending it here. So, like I said, I'll see you tomorrow. Hopefully in the morning, and we'll get some work done before the football game. So yeah. Anyways, bye.